This is Charles Young, and I'm back with another vignette about radioactivity and finding more hot rocks. In this video, I want to talk about the advantages of tones over the random clicks that a typical Geiger counter uses to indicate radioactivity. Let's start with a stock Eberline ASP-1 and show how effective it is at finding hot rocks. Now, some collectors use a pancake probe, so let's see how well it works for finding and localizing a hotspot. I'm going to use this piece of radioactive monazite to demonstrate. So let's turn on the meter, and I'm going to put it on the 1000 range. And we can see we've got a background of about 100 or so. But as I'm sweeping back and forth over an area, looking for a sudden rise in activity that might indicate a specimen, I may, if I pay real close attention, recognize that there's some increased activity. This requires a lot of concentration, and it's very tiring over an extended period of time, I can tell you from experience. So that's the pancakes. Now, serious collectors use a scintillation probe because it is more sensitive. However, greater sensitivity means more background noise, which can be very annoying and may not even lead to better results. Let me demonstrate. So I've set the meter range to measure the background, and it's about 12,000. So now as I sweep back and forth looking for this hot rock, because of all the noise, it's even harder to find it. You may notice a slight deflection in the meter if you're paying close attention. Listening to this noise and concentrating all day is, for me, intolerable. In fact, let me turn off this noise because I just can't stand it. So, it was this experience that led me to the idea of using a microprocessor to convert this random noise into something more pleasant to listen to. At the same time, it would free up my eyes and ears and brain to enjoy the surroundings. So if you go back to my earliest prospecting videos,
okay, it doesn't seem to be this way, more this way.
You will see me using an early prototype that converted the random clicks to steady clicks.
Now when I find the hot spot, I move a little bit one way.
They got faster as you approach the source of radioactivity.
Move a little bit the other way.
This worked very well.
A little bit down.
Eventually, I decided that tones would be even better.
So it seems to be right in here, right where this piece of quartz is.
I'll demonstrate this using a box that converts the probe signals to tones. Now I'm using the same probe with the same specimen, but instead of clicks, we've got tones. You can see and hear that specimen is detectable at a greater distance, and it's much easier to localize. Also, the squelch silences the tones and saves battery because the speaker is the greatest consumer of power. I'm going to install this little board with a microprocessor and make a small change to the audio system. But first, let's look at the meter circuit to see how this works. When the signal enters the circuit, it is conditioned and compared to a voltage threshold, which eliminates noise and determines the sensitivity. Afterwards, the signal passes through this header, which was designed for an optional pulse height analyzer board, or PHA. Instead of the PHA, I'm going to install my tones board. The tones will then be routed over to the audio circuit to be output on the speaker. On the schematic, you can see that this header has all the important connections, including the signal and the threshold. This is all the tones board needs to perform its magic. Instead of the PHA circuit, we will insert the tones board. The tones will then be taken from the header and jumpered over to the audio amplifier. So this is what it looks like after the board is installed, plugged into this header. And here is the jumper wire that takes the tones to the speaker. So let's try it out. Hook up the same scintillator as before. And okay, that's starting to sound like tones, isn't it? Now, when it first comes up, it measures the background and sets the squelch, and now it's ready to operate. So let's see if we can find this hot monocyte. Yeah, it works just like it should. Okay. So that's how to modify this ASP-1 to give it tones. Now we can enjoy the dulcet tones while searching for hot rocks. If you want to purchase one of these Eberline ASP-1s converted to tones, send me an email. Also, I sell another meter called gammadogger, which has the same technology and ergonomics to maximize your efficiency and comfort while prospecting. Now, get out there and find more hot rocks.